So thanks everyone for attending this breakout session. We're excited, I know, to talk to you a little bit about the more complex risk type stuff. So the first we'll hear a little bit more on the risk alleles and low penetrant variants, and then we'll move into polygenic risk scores and really things that fall outside of the normal Mendelian pattern, and thinking about how to deal with them and how to sort of approach them from a clinical lab perspective. So this is just an overview slide from ClinGen, really about what the goal of it is. And what we wanted to do is just sort of place where we think the stuff that we're working on is. And so it's just understanding where the risk alleles and the polygenic risk scores and that sort of stuff, where they fall. And so a lot of what we're sort of doing, at least for the risk alleles and the low penetrant stuff, is thinking here a little bit about the variant pathogenicity and how to deal with things from a, sometimes my mouse does that. Think about things from a, how to interpret these variants, how to look at them, how to study them, and then a little bit how to disseminate this stuff as well. And the PRS stuff, I think, actually falls in here too. How do you actually curate PRS scores, and how do you actually think about developing them and then actually launching them and stuff and improving them? So I think you all are aware of some of the curation tools. And so a lot of the stuff has, as I mentioned earlier, been focused on the Mendelian side of things. And really what the goal of these two working groups are to start pushing that boundary a little bit more into the more non-Mendelian stuff. Again, so we'll explain a little bit more about what we mean about risk alleles in the next couple slides. But really it's things that maybe just don't fit your typical pattern for Mendelian disease. And so this is something that we're hoping to sort of take a lot of the tools that have been developed in ClinGen already and think about how to apply them to these more non-Mendelian risk things. And this is a pretty well-known slide, but just to sort of give you guys an idea of what we're talking about. So I think everyone's aware, Mendelian disease sort of sits in this fairly, or very rare variants, typically pretty high effect size. We then have these variants that are sort of more low frequency variants with intermediate penetrance. And this is probably what the first group, my group, is going to talk a little bit more about. So these sort of low penetrant variants that really start getting to be a little bit more common sometimes, and really sort of don't quite have this high impact into things that are actually even quite common, and still have some sort of noticeable increased penetrance, but not a very high penetrance overall. So still pretty low overall absolute penetrance, just an increased risk of disease. And then you get down to really the variants identified by GWAS studies, which are really low effect size, but oftentimes can be fairly common. Typically, this is because of how they've been identified via GWAS studies and to be able to have the power to identify them. And what you'll hear a little bit more in the latter half of the talk is the PRS score, which is sort of combining these in such a way to sort of get actually to this realm. And so we'll hear a little bit about sort of the interplay between these ones as well. Just to give sort of an idea of terminology, we do have a slide in ours that touches a little bit on this a little bit more, but the penetrance here, what we mean is sort of if someone has variant, someone has something that is low penetrance is a typical Mendelian variant that has a high penetrant and inherited in a familial manner, might have 80% penetrance or greater depending upon the condition. Something with moderate or lower penetrance has something less than that, where we still haven't necessarily quantified that. We'll get into that a little bit in our discussion. And then the risk alleles we think have even less effect than that. And then when you start looking to PRS, the penetrance actually can be calculated sometimes as like a PPV type thing, but it's sort of given someone who is at high risk, what's the chance that they might actually get disease? And it typically can get to the order of some of these risk alleles, sometimes even greater for some conditions. So common, I think we're going through some of these terms. Common here, I think, does vary. We will see some risk variants that we talk about that are actually somewhat fairly rare, but still more common than you might expect. So really, when we think about common in the risk framework, what we're talking about are variants that are more common than more common in the population than the disease prevalence is. And so therefore they can't be 100% causative for that disease because they're more, you see them more frequently than you would expect to see the disease in the population. So that's sort of what we're thinking of, and that's why we think of these things having reduced penetrance, because they can't and they don't sort of always lead to disease. For analytical validity, this is really the technical performance of how well you can detect variance. And I know this is pretty important sort of in the PRS scores of how well you can detect the individual variants. In the Mendelian, in the low penetrance and risk allele framework, the analytical validity really is similar to what you'll see with any sort of assay. So we're really typically looking for one or a small number of sites in our study or in our work, as opposed to the PRS stuff where you're looking at hundreds to millions of sites and understanding sort of how well those sites perform as a whole. And then clinical validity and clinical utility. For the clinical validity, it's sort of how important or how correct is this assumption. So this is actually pretty important for both of the work we do and for the PRS stuff, but it really is, what is that that odds ratio? Is there a significant odds ratio is there a significantly increased odds ratio for disease, whether you're looking at sort of maybe a risk allele or a PRS, which is separate from clinical utility. Is that increased odds meaningful for any reason? And so we'll touch on this. I think a lot of what we are looking at in the low penetrant risk allele stuff, clinical validity is sort of where we are determining whether or not something should be reported, or whether or not something should be classified, I should say. And clinical utility maybe is more whether or not something should be reported. And we'll touch on those when we get through our risk allele framework. So that was just sort of to get everyone on the same page of where we are and why these two groups are sort of presenting together. And now we'll touch on a little bit more of our aspects from the low penetrant risk allele framework. I should also say, please, if you guys have any questions, put them in the chat. We'll be monitoring the chat, or just raise a hand or whatever might be the easiest. And Marcy and Ryan from our side for now can take a look and let us know if anything come in. But if you have any questions, if you have any comments or anything, please don't hesitate to ask. It is meant to be sort of interactive and not just completely didactic. So just to give everyone again the groundwork, what we're thinking about for risk alleles, and we'll get into these again like a little bit more detail as we talk about the framework for them, but it's typically things with very low penetrance or small effect sizes. So I just put down 3 common ones. I could give you a list of 10 more fairly common ones that everyone probably knows about. You can see the odds ratios here are all actually fairly low. They're all typically at least 2 is sort of a fairly decent standard that we look at, although that's not necessarily set in stone, but at least 2 is sort of like a good starting point for when you start considering these things. They're all single variants. We do see some that are multiple variants. APOL one's a common one that only matters in like sort of the recessive form. Some of these actually have different levels of risk, whether they're heterozygous or homozygous. So there's different levels of sort of like the increase in odds ratio dependent on that. But really what we wanted to, this is just an example to see what we're talking about. It's really things that are usually single alleles or small number of alleles that have a fairly modest or lower effect size, basically over baseline. And these are all ones that if we should to have very good data to actually be classified as risk variants. So that's why we're focusing on some of the ones that are more well known here. As opposed to low penetrance, which is a little bit different, they have like fairly reduced or fairly appreciable penetrance. So these are ones that at least 10% up to maybe 40, 50% of the time, someone who has this variant is going to get some disease. And so there's actually quite a bit of variants that fall into these, and these are ones that actually tend to be really difficult to assess as well, because they're typically assessed in more of the Mendelian framework, but maybe they're slightly more common than you'd expect, or there's a really clear lack of segregation. And it's hard to maybe get the case control numbers because maybe they're not as common as some of the risk allele stuff. So these are ones that I think you'll oftentimes see people struggle with in terms of how to sort of present and how to actually get the data for this. But again, just sort of giving you the idea of the difference between risk alleles and low penetrant variants, and sort of how we're thinking about them. But obviously, this is all great, but you actually need a way to interpret these in a framework and a thing to do it on. So that's what we'll talk a little bit about today, is like, how do you actually map some of these things into an actually interpretive framework? So just quickly, some of the challenges for classifying these types of things. The ACMG AMP guidelines did suggest some terminology, but there was no framework really for these things. I mentioned this already, that these are usually single alleles or single loci conferring a high risk of developing disease, but they're usually more common than you expect. Difficult to define sort of when low penetrance becomes high increased risk, and this is something that is actually very challenging, and we'll touch on a little bit, but sort of the boundary between low penetrance and risk. And as I mentioned, it's going to be hard to use some of the traditional measures for classifying things, and so that's something that we'll touch on a little bit in our framework as well. So this is from a study a few years back now, but sort of just looking at what terminology people use for defining these things. And you can see there isn't really consensus, and this actually obviously leads to some issues. There's no real standard way for people to classify these variants, and so that is really one of the reasons that our working group started, was to sort of help establish this terminology, help sort of get some standard here, and also then help create the framework. It's also pretty high discordant rates for low penetrance risk alleles. Again, this is a slightly older data, but I did look at ClinVar and you do see sort of similar patterns still holding up, in that most of the variants that are initially classified as like a risk factor or as low penetrance actually still end up being the ones that have the highest levels of discrepancy, even after consensus, trying to determine consensus. And so it's pretty clear that something, a more standard framework needs to be developed for these. And again, that's sort of the goal of our working group. So one of the things we wanted to early on was sort of just establish what the one, what our working group should be doing, and two, what the terminology we should be using, because we felt like at least if we can get the terminology out there and get people standardized on that, that will at least lead to less discrepancies. And then sort of getting the framework in place afterwards would be the little bit harder work, but also would be informative. So we did send a Likert survey out to the ClinGen community. I'm not going to show you all the results here, but just as a quick summary, we did have strong consensus for one, including categorical information on penetrance on the report. So if you can say what the penetrance is, you should, or at least some level of what the penetrance might be. And that could be either classifying something as a risk allele or as a low penetrant variant, or as you see in the next bullet point, if you actually can get the absolute penetrance, that is something that I think we all want to strive for, right? That would be an ideal thing to be able to put on the report. Although that is difficult for most things in the current in our current knowledge, and so that is definitely a future direction, but something I think we wanted to be aware of, and that ends up being important when we talk about the terminology, because that really is I think where we want to go for the future. I will say people did like using the term risk allele. We had many different options for this, and risk allele was sort of the key winner. As well as using qualifiers for risk allele, established, likely, and uncertain risk allele. And this was actually what was recommended or suggested early in that ACMG AMP guidelines paper. It sort of is what people gravitated for, having sort of risk allele be the term instead of risk variant or some other modifier, some other things. And then having these qualifying terms, so established risk allele, likely the risk allele, or uncertain risk allele. There was some moderate consensus, but maybe not as strong, for using the term pathogenic low penetrance over pathogenic reduced penetrance. And really the difference here is that low is maybe a little bit more categorical, where reduced, you sort of have to know what it's reduced against. And so we can probably establish some thresholds to some level of what we mean by low penetrance, where when you're just saying reduced penetrance, it's hard to determine that. And I think that is why the term low penetrance sort of had a slightly stronger consensus for use than reduced penetrance. So this was sort of the what we did or from the surveys. So what we wanted to do, I said, is sort of, okay, let's actually now have an idea of how to use this terminology. And so we do have a white paper up on the ClinGen website, which sort of goes through this. And so the idea is that you might have a risk framework, which is using a lot of either case control studies or meta-analyses, potentially GWAS studies, depending upon what it might be, where you're getting some more like statistical level of information, and you may or may not have some functional studies as well. Separately, you have a sort of more common Mendelian framework, where you might be getting, typically what we do is a path likely and uncertain, sort of the normal ACMG AMP guidelines. And we actually wanted to get to the point where we actually think there's equivalent confidence here. So if something's established by this framework or established by this framework, they should have the same level of confidence in them. And the reason we are thinking this way is because we're actually getting to the stage where for some of these low penetrant variants, there's enough genome exome type data out there that you actually can start doing case control studies on more and more of them, where typically it's been sort of in the realm of the risk alleles that you've been doing this sort of studies. And so as you get more and more genomes, you're going to be able to do more and more of these sort of maybe like really large case control studies and establish really good statistical significance. So we wanted to make sure that there's an option where a low penetrant variant might actually come through more of this framework as opposed to that framework, because it has stronger data here. But we want to be able to establish equivalence confidence between the two of them. And so then the idea is that from this equivalent confidence, you could, once you had the overall, the final classification, or how you get to the final classification of the final terminology would actually then be based upon the absolute risk. And so things that fall into this category would end up being considered risk alleles. Things in here would be low penetrance, things up here that are high penetrance. I will say that we have this potential for moderate penetrance in here. It's unclear if that will be our final recommendation to include that, or to sort of only include low versus no sort of terminology. And sort of see that is sort of what we are currently suggesting, is that there is sort of your standard pathogenic, likely pathogenic VUS. And then you have these qualifying terms when something does fall maybe into this bucket here for pathogenic low penetrance and likely pathogenic low penetrance. And then things that really fall into this category would be established, likely risk allele or uncertain risk allele. And one other key thing probably to bring up here, uncertain risk allele isn't meant to be everything, sort of like a VUS sometimes might be. It is really only meant to be when there has been data associating something as a risk allele, and either it's not strong enough or it's been refuted. And so it's really meant to be a certain type of variant that someone has said something about it before, and you feel the need to sort of say, actually, this doesn't quite meet the criteria, and we shouldn't necessarily, we should classify it with a little bit lower of confidence. Does that, hopefully that makes sense. I'm not sure if we have any. We do have a couple of things in the chat. I don't know if Marcy and Ryan, you want to take a look at those while I keep going, and see. You can feel free to interrupt me.
Well, it was a little bit more specific to ClinVar, so okay. I think our ClinVar folks are taking.
Are on it. All right. Thanks, Melissa. All right. All right. So one thing that is obviously clearly important here is how do you determine separating between these buckets, basically. And so we did survey the community there. And so this is, again, we were trying to base things off this term absolute risk. And what this is sort of saying is sort of like, this is different terminology and sort of mapping what the different terminology is and sort of what we're trying to get to. So we're trying to get to sort of this absolute risk or absolute penetrance level, as opposed to sort of maybe more of a relative risk, odds ratio, effect size sort of thing. Obviously, I think understanding the effect size is pretty important, and that does sort of get you whether or not you want to classify something at all. And so this does come into play in terms of potentially reportability, but in terms of the terminology, we did sort of want to focus on the more absolute risk level. And so what we did is we asked people, okay, what should be the boundaries between, one, even calling something risk, two, calling something risk versus low penetrant, and three, calling something low penetrant versus moderate penetrance. And so for the relative risk threshold, this is, like I said, just, it's a little bit different. This is more of when should something be even considered to really be at a risk allele that's worth sort of reporting on its own. So it does sort of get more into the effect size relative risks thing. And when we asked this, there is pretty actually good consensus for returning variance at the odds ratio of around 2 or 3. I will say people are very opposed to doing something at a much lower odds ratio that you might typically see in a GWAS study, something that's close to like 1.2. There really does seem to need to be some stronger level of evidence, or stronger level of effect, or I should say, for this variant. People also didn't want to get too high, which is reasonable. And so I think there is some cutoff potentially around 2 or 3 that we could consider for even considering something to be a risk allele. And then sort of once you have something that you might want to consider, how do you sort of determine the difference between low penetrance and risk? I will say there's definitely less consensus here. You can see these numbers. This is like a Likert scale, and we just converted strongly agree to 2, agree to 1, neutral to 0, disagree to -1, and strongly disagree to -2, and sort of sum them all up. So it's a kind of crude measure, but a way to sort of look at the difference between the two of them. You see these scores actually get fairly high in terms of their score. There's definitely less consensus for what the boundary should be, low penetrant versus either higher penetrant variants or typical Mendelian variant, and risk versus low penetrant. You can see it's probably somewhere 10% does have some pretty good understanding of if something's starting to get to like a 10 to 20%, 10 to 15% absolute risk, that it's probably good enough to call it a low penetrant variant, although again, this isn't necessarily perfectly clear. And then something on the higher end that really is not good consensus right now. I think this is something that we do have to tackle a little bit stronger, but it is probably something closer to 50%. Again, I think this might mean there's a little bit more wiggle room at the end of the day, but it's sort of showing you where people in general lie. So this is something that our working group has unfortunately not been able to finalize or tackle yet, and something that we know is really critical and really crucial for us to do, and so something that we are very much focused on over probably the next year of really trying to dive a little bit more into this, because this is going to be pretty important for sort of how do you help set these boundaries and these thresholds to sort of allow people to have a little bit more consensus on terms of how they're actually calling these variants. All right, I'm going to stop there and pass it off to Ryan. I'm not sure, Ryan, if there's anything to touch on before then.
Well, I did note there was a very thoughtful question about if you have variants that are currently being classified in the kind of high penetrant system that are being called VUS or pathogenic, and we're thinking about kind of maybe updating their classification into this risk system using some of the terminology that you shared that the ClinGen community is kind of settled on. Should we do that now, or should we wait until we become more finalized with our framework for classifying them? I think that's a really good question. You know, there's obviously a lot of diversity in the way people use these terms now. As Matt mentioned, there's people calling the same variant VUS, pathogenic, risk allele. We can say clearly that at the end of the day, for us, for the risk alleles at least, it's going to be called a risk allele. And then the classifications would be uncertain risk allele, likely risk allele, and established risk allele. So I think it's reasonable to call something a risk allele at this time. I guess you may not want to jump the gun and call that established risk allele if you don't feel 100% confident on that, because maybe at the end of the day with the framework it might end up being a likely risk allele. So that's just one thing to keep in mind. But I don't think we have any strong recommendations for how to handle the situation. But we're just kind of showing you all of our group's work, and hopefully that'll lead to more consensus within the community.
Yeah, and one thing we do want to touch on that we have a little bit of a comment at the end, we'll see, hopefully we have time to get there, is one thing we really want to do as a working group is start engaging with the disease-specific working groups, because we do want to start applying this framework, and we don't necessarily want to apply it outside the context of like the disease groups that they're already sort of working on these and thinking about them. And so we do want to start engaging the different groups in terms of how to start classifying some of these variants and how to actually get those classifications into ClinVar, and who they should come from and all that sort of stuff. And so that, I think we have a slide at the end that we can touch on a little bit more that should foster some discussion. But that is sort of the, that is a goal for our working group that we'd love to really get into, is sort of actually classifying variants now and working with the disease-specific groups to do that.
All right, so let me quickly reintroduce myself. So I'm Ryan Schmidt. I'm from Children's Hospital Los Angeles and University of Southern California. And it's been a privilege to work with Matt and Marcy and all the rest of you in the context of this working group. So my main goal is to kind of sum up some of the work we've done over the past year, which has been focused on risk alleles. And Matt kind of gave you some of our best definitions of, at this time, of what a risk allele is relative to a low penetrance variant, relative to high penetrance variant. So what I'm going to tell you, it's pertaining to risk alleles. In early 2020, within the working group, we created 3 subgroups to focus on evidence curation of risk alleles, the classification framework for risk alleles, and then reporting guidance for risk alleles. So the output of those for evidence curation, we're just coming out with a white paper, just trying to tell the community all the things that the working group thought were important in the evaluation of literature and evidence for risk alleles. So we have this draft text that we'll ultimately share that kind of summarizes those points, and hopefully kind of brings the community to a good, strong foundation of knowledge. For those of you that are experts, maybe there might not be anything new in there, but we hope to really kind of at least give folks a starting point to how to look at this type of evidence. For the classification framework, I'll share that in some upcoming slides, but we have draft classification criteria and tiers, and we're currently evaluating the framework on some candidate variants. For reporting, we're not trying to be prescriptive and tell you what your laboratory should report or not report, but just give you considerations to think about for factors that might drive your decision to report a risk allele or not in various testing scenarios. And then also potentially share when we have areas of consensus reached within the working group. So overall, our plan is to assemble this into a single manuscript within 2021. Can we go to the next slide? So just to give you the high level outline of our topics that the work group thought were important for evidence curation. So it's important to look at the study design, exactly defining what the disease phenotype is. Remember, that can vary across different studies. One of the most critical elements is to match the cases and controls, and also come up with a solid definition of what is a case and what is a control. Remember, in theory, the the cases are going to have the disease and the controls are going to lack the disease, but it can get messy in real life scenarios. Defining the variance or variance of interest and how you test for them, the genetic model that the association is being evaluated in. So for example, dominant, recessive, or allelic models, calculating statistical significance and the strength of the effect, potential sources of error, so technical variation, different platforms, for example. Poor matching is one of the most important ones, as I suggested. Inappropriate statistical analyses, most commonly not performing multiple hypothesis correction. It's very important to have replication of the study results, and also in this white paper text, we have some practical takeaways that we share with people. This is just a high-level outline of it. We haven't released this publicly yet. So next slide. So now we'll get into our proposed classification framework. So again, this is just for risk alleles. It's not necessarily focused on the low penetrance variants. And really the main driver of classification for these variants are association studies. So kind of at one point we had worked from the ACMG AMP sequence variant interpretation guidelines, and when you really go through them one by one, many of them are no longer relevant to risk alleles, and the major driver becomes the association study, this genetic evidence. And the key thing to note about these criteria for association studies is the criteria results from the entire body of evidence associated with a candidate risk allele. So it's not, you don't say that any individual study by itself is strong or very strong. It's the collection of those that contributes to that classification criteria. So it's similar to what we do for the high penetrance variants. When you're looking at segregation data, you're going to take multiple publications and kind of wrap that together to get your evidence strength. So for these association studies, the main factors were the evidence strength. Typically that comes in the form of the number of individuals studied, replication of the results. So you want to see that the association is still present in independent cohorts, and then the risk of bias in the study design. Can we go to the next slide, please? So we ended up having 3 levels of evidence strength supporting a disease association. So supporting a disease association is kind of like your pathogenicity criteria. Very strong is these are somewhat loose guidelines, but it's saying we have over 1,000 individuals studied, so at least 500 cases, at least 500 controls. There's extensive replication, preferably at least one meta-analysis with little between study inconsistency. And when you look at the study design, bias could not reasonably affect the presence of the association. So scientifically, this association, it's not coming back. We're not going to wake up tomorrow and have some publication that just throws it in the garbage. That's unlikely. You can sleep well at night. That's very strong. So next slide. So strong, it's kind of those same 3 factors, but at this point you only need more than 100 individuals studied, over 50 cases, over 50 controls. You do need replication, and moderate between study inconsistency is permitted, but there can be no obvious bias that could affect the outcome. However, the fact is, with many association studies, sometimes based on how they're described in the literature, it can be difficult to fully evaluate the level of potential bias, and there may be missing information where you can't fully evaluate it. So if you have any of those 3 factors, you'd be in the strong category. You would no longer qualify for very strong. So next slide. And then limited. So limited is just saying that an assertion has been made, but the level of evidence at this time does not meet the requirements to be considered strong or very strong. you have a limited number of individuals, you have large between study inconsistency, and significant potential for bias in the methodology. So any of those three factors would lead you to be limited. And we'll get into what that means if you're limited in a second. Next slide. Okay, so functional studies. So functional studies can still be considered in the context of risk alleles. Remember, with risk alleles, the variant itself does not have to be the causative factor. You can have that variant, in theory, be in linkage disequilibrium with the causative genetic factor. It can be, like what's known as a tag SNP. In the end of the day, the variant itself, it can still be a risk allele, even if it itself is not directly causing the effects at a functional level. So the functional study is not required, but when you have functional evidence, that we consider that supporting. So it's considered, but it's a little weaker in terms of its evidence strength than in the high penetrance system. Remember, that would be a strong criteria if you have a functional study supporting pathogenicity. Here, it's just kind of supporting, and then that may suggest that it's a direct effect through that variant. And the things to consider are that the study, it needs to suggest that the risk allele alters gene function through a mechanism that's biologically plausible and that would be linked to disease risk. Note that it may not be the same mechanism as the high penetrance variants. Remember, sometimes you have these risk alleles that are associated with a phenotype that has nothing to do with the high penetrance phenotype for that same gene. And then one really important thing to note is that with risk alleles, you might actually be measuring a smaller effect in your functional studies. So these may be alleles with the partial loss of function. Let's say it's an enzyme, for example. So your functional study really needs to be tuned to detect these more subtle effects. And you don't want to have a false positive functional study where you have just a very small change that could be occurring by chance. And then you declare that there's a functional effect there. You want them to be well validated functional studies. And you want to kind of know what the output would be for a benign variant or a variant that's not a risk allele on that same assay. So next slide. All right, so then for criteria that refute the disease association. So we have scenarios where the association study evidence will be refuted. And they're rare, but they happen. We wanted to build in a mechanism for that. So the thing with the association studies is that even for variants that are established risk alleles, there is a chance that when you perform a number of studies, some of them may not show a statistically significant effect. And that depends on random chance. It depends on the study design, the number of individuals. So we recognize that you can see in the first bullet point, last sentence there is a level of between study inconsistency that is reasonable to observe that does not refute the presence of an association. So that's normal. But there are scenarios in bullet point 2 where there was an assertion made, and now we do a much larger, well-controlled study, and it's really designed in a similar manner, and the association's not there. So in those cases, we would suggest that the association is refuted, but it really requires greater evidence strength and a similar design that lacks the presence of the association. The next slide.
And Ryan, one thing about negative criteria too is that functional data for risk allele is not refuting.
Yes,
negative functional data.
Yeah, we touched on that, but yeah, so you don't need functional evidence, and negative functional data is not refuting. Thank you. Okay, so how do we put it all together? Sorry for all the text on my slides. But again, the community told us we are having 3 classification tiers: established risk allele, likely risk allele, and uncertain risk allele. And again, it's really driven by the association study evidence. It's almost simple relative to how we put things together for the high penetrance variants. But if you have very strong association study evidence, you're an established risk allele. You may or may not have the functional evidence, but the functional evidence alone it's just supporting, and it doesn't change the classification tier. Same thing for likely risk allele. It's strong. That would be strong evidence, but not very strong evidence. You may or may not have functional study evidence. And then uncertain risk allele would be limited evidence, or scenarios where you have refuted association study evidence. So next slide. And then lastly, for this risk allele framework, there were some concepts that were considered by the working group but not included at this time. That includes so-called aggregate association studies, where you're aggregating variance, similar variance by class, for example, loss of function variance, and also computational prediction data. Next slide. So I told you about evidence curation. I told you about classification framework. Now let's talk about some reporting scenarios. These are the scenarios that were considered by the working group. Sorry, the wording's a little confusing here, but most of the time, those of us in our laboratories are encountering these variants because we're doing a gene panel looking for high penetrance variants, and then we're encountering these risk alleles that are present within those same genes. So that's kind of what those top 2 are. You're doing a diagnostic panel, and indication matches means that the risk is for the same disease as the high penetrance variants. Indication doesn't match is saying we found a variant in that gene, but it has nothing to do with the gene panel, the phenotype for the high penetrance variant. It has something to do with melanoma risk, for example. Secondary findings on exomes, prenatal diagnostics, healthy genome screening, carrier screening, and again, the scenarios where the indication matches or the indication doesn't match. So the confusing one is the one there where the indication doesn't match, and my understanding of that is that you have a high penetrance variant that's tested for on carrier screening, but it also conveys risk for another phenotype. So it's a pathogenic carrier variant for one condition that's high penetrance, but it also has risk for something else. All right, next slide. And 2 more slides for me. So here's an example of one of the variants that was considered, probably in that most important scenario for most people. You're doing your panel and you find a risk allele. Should we report the risk allele, and how should we report it? So this is an APC variant that leads to elevated risk for colorectal cancer in the Ashkenazi Jewish population. So it's pretty well established. It's now listed in the NCCN guidelines. So the consensus of the work group is to report this type of variant, but not necessarily to provide an overall result of positive. So that's kind of that case level result that people might put at the top of the report: positive, inconclusive, negative, something like that. The working group suggesting you might not want to say positive. You might want some type of alternative case level result, like risk allele identified, and you may want to consider reporting the risk alleles in a separate section, which helps you to communicate the actual level of risk associated with them. Again, the most important thing is that the audience, the medical practitioners, the patients, they walk away with an accurate sense of what the risk is. So the things that we can do to convey that better, to put them in a separate section, to use language that clearly communicates a level of risk associated with the variant. that is very helpful. Next slide. And then click a couple times, maybe just to make everything appear. This is just some figures from a publication that Matt and I had been involved in, but nicely outlines some potential considerations for laboratories when they're thinking about reporting risk alleles. So the effect size, they might have a cutoff, whether or not there's an effective intervention, the severity of the condition that the risk is associated with, the disease prevalence, and then the risk of the intervention to help out with the condition. So this was kind of outlining a potential scoring system to evaluate all those factors and add them up. And on the left, lower left, you're seeing kind of a decision tree to apply this type of thinking. And then depending on the laboratory's preference, you may decide to report or not report the risk allele. So this just something for laboratories to think about. Again, as a working group, we're not trying to be overly prescriptive to tell labs what to do or not do. It's very context specific. So I'll stop there, and then Marcy is going to take over, and then we'll be happy to answer questions later.
We're at about 45 minutes in, so we wanted to present a couple of slides on a couple of example variants, but maybe we should stop in just the time.
No, we have. I mean, Hannah and I don't think we need the full 45 minutes. So
okay.
You can go ahead if you want.
Okay. All right. Maybe we'll do one, and then not the second.
I don't think it'll take super long. I'm good at talking fast too. So.
All right. All right. Go ahead, Marcy.
So my name is Marcy. I'm one of the genetic counselors, and I work at the Lab for Molecular Medicine with Matt. And I just kind of wanted to walk through a couple of examples of putting this into play. So obviously, as we've hit on, there is everything's a spectrum, and it's not always easy to draw these lines between categories, but we do have some recommendations and some guidelines for how to interpret these risk alleles. So we asked the group members to put some of these through kind of the framework that we had established and see what we could do with it. So these next couple of slides are just showing you kind of what we gave everybody to use. So this is just kind of a template for putting together the evidence for a particular variant in terms of pulling all of the data together. And if you can show the next slide. Just showing again the classification criteria in terms of evidence for association studies and functional studies that would either support or refute a disease association. So just this would be what we give everybody, and then you can go to the next slide. The proposed scoring system for the risk alleles, again, as Ryan and Matt had walked you through, the established risk allele, likely risk allele, and the uncertain risk allele, and kind of what you would put together to come up with these calculations at the end. And so I'll show you just quickly two variants. There's a lot of text on here, but you don't really need to read it all. It's just kind of to show you what this looks like when you put it into play. So this is a ProKR2 variant that is associated with Kalman syndrome. And if you can go to the next slide, I've just kind of highlighted through what these are the areas that we would recommend evaluating in this particular variant, and showing that in this particular, in this text here, we've put in all of the things that we've been looking for. And then at the bottom there, kind of walking through, we conclude that it's a likely risk allele given the strong evidence from the association study and a supporting functional study. But it kind of walks through all the different elements we would recommend hitting with this type of variant. And we have one more briefly to go through, but this is, again, as Ryan said, one of these variants that can come up when you're doing something like a hearing loss panel looking for Waardenburg syndrome genes. You'd look at MID-F. And then you can find this particular variant that's associated with increased risk for melanoma. So if you go to the next slide, again, the same thing as the last one, where we just kind of showed the different elements that you're looking for in evaluating this type of variant in terms of the association studies, the prevalence, functional studies, and on the basis of all of that, kind of in aggregate, what we were coming out with was an established risk allele for this one. So this is just to show you kind of a demonstration of the concept of how these risk alleles could be run through this framework. just to show that we can do it. But then the question is kind of how this is maybe a demonstration of the concept, but how does this translate into the larger ClinGen community? There are obviously many different disease and variant groups. How do we translate this recommendations and guidance into all the different groups that pull the community together? And I think the idea is kind of to serve as a starting point or a reference, and not to be in trying to take over interpreting anyone's variance, because there's obviously a lot of nuances and subtleties that go into any one specific group and type of variance that you guys are looking at. Go to the next slide. And we've talked about this a bit already, but again, this was kind of demonstration of the concept for the risk variance, but there's obviously a lot of work that needs to get done in terms of what are the similar and what are the different considerations that need to go into reporting and evaluating the low penetrant variants. So how do we factor in the kind of Mendelian segregation evidence there, and how does that factor into the guidance in terms of how you interpret these variants? So that's definitely a step that needs to happen in the future. Where these thresholds exist, you've seen a lot of rainbow charts. There's a lot of spectrums going on here. So where you call those lines in between variants is something that needs probably not an easy answer, but it needs to be considered more thoroughly. So yeah, just another demonstration of we've kind of hit on the risk variance now, but the low penetrant variants, which have some overlap with the considerations that you keep in mind for the risk variance, but also some similarities to the more high penetrant variants. And so what are the factors that we need to consider in terms of interpreting those variants is kind of one of the big next steps. And then just to acknowledge all the people that have been part of the group. These are some of the more active recent members of the group, but we have other people that have been part of our regular meetings. So thank you to everybody for participating. And I guess with that, we can turn it over to some questions if we have time, or those can wait for the end.
Yeah. And thanks for everyone. If you keep putting things in the chat, we can reply to them. So or take questions after Jen and Hannah are done. But thank you. Hopefully this was helpful. See, it is hard. There's a lot of work still going into it. We're hoping to have some more guidance for you soon, especially on the risk allele stuff, and then some of the other stuff afterwards. So, all right, you can stop sharing now if you guys want to take over.
Sure. I'll start sharing my screen. All right, can everyone see it? I'm assuming so. Great. So Hannah and I will be speaking today on behalf of the ClinGen Complex Disease Working Group. This really builds nicely off of the low penetrance group that was just speaking, and so we'll just dive into it. All right, so the Complex Disease Working Group is primarily focused around the idea of polygenic risk scores and what the place of polygenic risk scores are in the clinic. So for those of you who aren't familiar with polygenic risk scores, essentially what it is taking a lot of risk alleles from across the genome and summing them across to get a summary measure of genetic risk for a particular outcome or disease. And so that risk is then compared to the full population's distribution or the relevant population's distribution. And then usually both the relative risk and an absolute risk can be derived from that. But really it focuses on away from sort of a step further from the Mendelian variants than the low penetrance variants, usually with effects, the individual variance effect sizes are very small, but when summed together, you can have very large effects on the order of several, odds ratios of 4 or 5. And so because polygenic risk scores are an extension of trait mapping, typically they are built upon genome-wide association studies. Sometimes they look genome-wide, sometimes they're focused more on a select number of variants that are selected from these association studies. They depend on what proportion of the variation of the outcome is genetic or the heritability of the trait. And they can, it's more of an agnostic look across the genome, not focused on specific genes. So some of these risk scores are up to 6 million variants, but when summed together have large effects. And so this is sort of from an older review article, but I think it gives a nice overview of what goes into developing a polygenic risk score and how it fits within the clinical space. And so you start with these association statistics you pick the relevant sites, depending on how well they do in prediction of the trait in that group. Biometric, the second sort of area there, you can have different candidate predictors and you pick the best one. And then the idea basically being that once you have the summary score, your cases and controls will have different distributions and you'll be able to delineate who is high risk, intermediate risk, and low risk. And then once you have this genetic score, typically these are then combined with other known clinical risk factors, either existing clinical scores or individual risk factors, to have this sort of composite score with the goal of having personalized risk prediction. So somebody would be able to combine both the genetic risk and the non-genetic risk into this score and sort of get an overall metric of risk for an outcome. So the thing that we want to focus on for this is sort of how do we go from this genetic score to clinical translation of this risk score? And Hannah's going to talk more about this in a second, but I think it's really important that, it's important to focus on what we can address as this working group. Polygenic risk scores are a very large subject area that a lot of people are working on these days. And so we're really focused on how does this get, into clinical practice, essentially. And so to address this is the complex disease working group. The co-chairs right now are Mia at Hopkins and Carlos Bustamante at Stanford. And the overall goal of the working group is to, how do we promote standards in polygenic scores as well as these integrated risk scores or the composite scores I just mentioned, and the reporting of these results. And this sort of spans the entire pipeline of polygenic risk score development and validation and assessment, from the analytic validity, so are scores saying what they say they're saying in the data sets, to the clinical validity, the clinical utility. And so there's several goals that we've had as the working group set out, I think a few years ago at this point. And the three goals, I'll go briefly over them. We're going to talk more in depth of one of them is first to create a standardized reporting guideline. So what information do we need to know about the polygenic risk scores? How are you supposed to report them so that we can know? Because one of the major hurdles right now is that a lot of polygenic risk scores are developed within groups, and there's no way of directly comparing them so to get the best fit. The second one is to collaborate with other institutions and consortia and sort of different efforts to promote a shared language for this field. Right now, a lot of the language around polygenic risk scores is sort of adopted and carried forward from trait mapping, and therefore sometimes the language isn't as appropriate when we move to the clinical space. So making sure we have sort of shared language to make sure that across the entire pipeline, people are talking about the same thing and really being specific. And then the last one is sort of leverage the existing principles in epidemiology and risk modeling to advance the use of polygenic risk scores as a clinical tool. And so, I think that there are, we'll talk about more in a second, but there are sort of these unique considerations for polygenic risk scores of how we assess them in terms of both their utility as well as their actionability. So it should be noted too that this is the ClinGen Competencies Working Group functions within an ecosystem of other organizations and collaborations and people doing things across this entire pipeline. There's the newly formed PRS Diversity Consortium, which focuses mainly on analytic validation, mostly in diverse populations. So most of genetic research is done in European ancestry groups, and so doing it in non-European ancestry groups. And then their sort of realm or their scope goes up until basically a clinical validation. So like steps a little bit into it, but not very far. And then the emerge groups take the clinical validation and run it through clinical utility to the patient, so the other side of the spectrum. And as the ClinGen Competencies Working Group, we sort of bridge this gap and have sort of an iterative role where we go iterate between the two consortiums as well as external partners to ensure that there's curation with an eye towards clinical use, as well as ensuring best practices, again, with an eye towards clinical use. And so it's really forming a bridge to link together these two ends of the pipeline. And so the first thing that we're going to talk about, Hannah's going to take over in a second, is this first goal. So creating a standardized reporting guideline for adequate transparency, reproducibility, and interpretability of published polygenic risk scores. So again, just saying a way to assess the scores, we just need to know what they're doing. And so, this is really important to get any further down towards the downstream clinical implementation. So Hannah, do you want to take over, and I'll just tell me when to move the slides?
Yes. Okay. So hi everyone. So I'm Hannah Wand. I'm a genetic counselor at Stanford, but I also lead an effort here where we're looking into the clinical translation of PRS. So I've been a work group member for a while now, was pretty heavily involved in the beginning. So I'm going to go over the work group approach, and we'll specifically be talking about our first goal on the previous slide, which is around building this reporting standard. So I guess at a very high level, what our group has been trying to strike is this balance between, expert opinion and grounding ourselves in prior literature. We really want to develop a consensus, build it on, collaboration, and reduce the redundancy in the effort. So starting from the beginning here, just to shed light on, being more transparent about processes given the audience for today. What we started with is really having this intentional recruitment in terms of membership. So we had very diverse perspectives on PRS involved. We had people with expertise in biostats, epi, clinical translation, bioethics, implementation science, and really brought that group together. And even the first goal that we mentioned in terms of reporting standards, that was informed by the larger membership, not solely, by ClinGen or a subset of people. It was really informed by kind of the greater community and experts in this space in terms of what was needed as a first step. So we started off with that. And then from there, we asked our group, who else is working on standardization in our field? And that's more in that stakeholder assessment there. So that's really where we built our partnership with the PGS catalog in particular. They were also thinking about this idea of reporting standards, more focused, I guess, in the idea of curation and having a PRS repository and focusing on the informatics aspect of that. But it's also where we built like the NHGRI collaboration that Jen mentioned, particularly with Emerge. So after we kind of figure out, who needs to be involved, we moved to the next step of looking at the literature. We really wanted to assess, what is the variability in how PRS are used, how is it reported on, and then from there, what are good examples of standards or best practices, and how can we improve upon that? I'll mention, so this was in 2018, I think. Jen, correct me if I'm wrong. So I think PRS, it was rapidly expanding in terms of how it was, the extent to which it was published. But there really wasn't the extent to commentary or reviews to what we see today. So I do want to mention that, I guess, limitation in terms of what we were looking at that time. But using what we knew from experts, literature review, all of that, we asked ourselves, what is the field doing? What is it trying to do? And then how can we provide guidance in terms of meeting that goal? So that eventually led to the development of ClinGen standards, moving forward with publications. And Jen, next slide. Okay, so walking you through some of that initial, assessment process for our group, again, in the spirit of transparency here. So our expert opinion on the left here, it was that the field was rapidly evolving, in two ways. Really, the first way was that the methods and available data sets were quite different from, a few years prior. Then second, we really just saw that there was a premature or maybe like non-transparent clinical translation in terms of what was, being offered by different companies. So actually that was really the prompt for us to really want to comment on this and talk about what we saw in terms of clinical translation in our writing. And then from this literature review on the right side here, we essentially also saw that very, highly cited PRS papers were providing variability in terms of what they reported or didn't report. And also variability in terms of how much detail they provided. So this, I guess, prompted concerns in terms of reproducibility and interpretability, especially with a translational lens. So we kind of have that in mind. And then finally, I guess bottom left here, we had in mind the relevant principles or guidelines that supported transparency and rigor in terms of what we want to see with publishing. So in just a little bit, I'll give some examples on the different aspects here on this slide. And then next slide. Okay, so this is just another view in terms of our collaborator, the PGS catalog. They had done a similar assessment in terms of, assessing the state of our field. This is very independent from the ClinGen group, but, came to the same conclusions essentially as us, that in terms of reporting and all of that, very variable, does not support necessarily the generalizability and interpretability of these scores. So I mentioned already that we partnered with them. I'll mention that they had more of a lens on informatics. Complex disease working group with ClinGen had more of a focus on clinical transferability. But just good to know that there was this, I guess, second kind of independent study on this. Next slide. Okay, so all of this led us to want to address three things in our reporting standards. So first, we wanted to have more specific definitions and how people interpret or reproduce different things that they report on. Second, we wanted to incorporate what we already observed and saw in terms of best practices, in terms of evaluating performance. And then finally, I think probably most important in my perspective as a genetic counselor and clinical provider for this, we wanted to consider, how do we provide guidance for authors in terms of discussing the intended use of a PRS? So how will whatever they publish ease with the clinical translation of these published scores here? Next slide. Okay, so moving on. I just want to now provide examples of each. So a definition. So one thing that I think is probably, very much of interest for the group, very much of interest for like genomic medicine at large. What we observed was a lot of variability in terms of race, ethnicity, and ancestry reporting. So these we often found were conflated. So people variably use these terms with different kind of backings to them. The source of information, whether it was self-reported or grounded in genomic data, it was maybe not always provided or kind of variably provided. So we weren't always sure if it was appropriate or accurate. It was also unclear like how people handled admixed populations or, what were the downstream clinical implications of this. So this is just one example of an area where we felt like having a really specific set of terms and definitions and standards would really be beneficial for the field at large. And then next slide. There we go. Okay. So moving on to evaluation. This is really thinking about, what have we seen previously in the literature in terms of best practices. Next slide. Okay. So what we see here is snippets of papers that detail methodologies for constructing or evaluating a polygenic risk score. As I mentioned here and in the beginning, we really want to build on this prior literature, right? We want congruency in what has already been established or figured out. So we used this prior literature, and the next slide. We also built upon previous reporting standards. So this is actually a fairly common practice through building new reporting standards where you build upon, what has already been established. So the group statement has been, published more than a decade ago now, I guess a decade now. So we built upon these. I very much recommend the Equator Network for understanding that process in more detail. But we kind of built upon this, incorporated what we knew from what was published from current methodologies to create our current reporting standard now. And then next slide, Jen. And then finally, talking about clinical impact. So just an example of what drove this. Next slide. So we have here, unfortunately, this is largely absent from the literature. So this area is very much informed by our experts in clinical translation, including myself. We saw a lot of conflation in terms of people talking about disease risk versus diagnosis versus prognosis. The timing in terms of like testing versus outcomes versus potential intervention is quite varied, but not necessarily reported on in a standardized way. So what we really wanted to do is to come into this situation by strengthening the language around clinical terms so that they were more accurate and less confusing, I guess, in terms of translating to a clinical audience downstream. And the next slide. Just shown in this figure, kind of re-emphasizing, I guess, that point. We very much had downstream awareness in terms of clinical utility, despite the fact that currently a lot of PRS are focused on analytic and clinical validity. So yeah, just kind of summarizing with that. And the next slide. Okay. So a lot of what I said until now, focus on process, just for transparency with the audience we have today. This now is the paper that we were able to publish. Next slide. So this table just kind of provides a high-level overview in terms of items that we think are both necessary and then collectively sufficient in order to have transparency, interpretability, and reproducibility in terms of reporting. Next slide. So the last table just gave like a high-level overview instead of in terms of items. This slide, I guess, kind of breaks it down in terms of what we actually provide in our paper. So the top half, these are screenshots that show our recommendations on the guidelines at a very high-level way. So a very concise description in terms of what's needed in terms of, again, interpretability, reproducibility, and transparency. But for anyone, constructing a PRS or really wanting a concrete understanding of what goes into a PRS, I would highly recommend the supplemental table. So that's the bottom half of this screenshot. And I pulled out Ancestry as an example, just given what I showed previously in terms of the variability in reporting there. So this supplemental material really just goes into the weeds of what we think is important in terms of reporting. And then next slide. This is just another figure from our paper. It helps to map the experimental processes of constructing a PRS to the items that we include in our reporting standard. That's just more of an orientation tool. And then next slide. And then I also just want to call out that for a lot of PRS and what we're predicting in terms of disease, it's really not explained enough in terms of the genomics alone, right? A lot of it is common complex traits or diseases. So often what you'll end up with is a multivariate model that combines the genomics with their clinical information or demographic information. So I just want to call out that our reporting standard also addresses this nuance of multivariate modeling. Next slide. Okay, so that kind of, I guess, debriefed us on what's included in the model. At a higher level now, just thinking of it as like the whole, I wanted to emphasize a few points of utility. So first is that point of sufficiency. and thinking about points together being sufficient to report on something. So this item here addresses the category of risk model evaluation. And the idea is that all 4 of these points, distribution, discrimination, predictability, and calibration, and I believe in our reporting standard, we also have sub-analyses if they're relevant. All of these collectively comment on the idea of performance or evaluation. They're not necessarily overlapping traits. So we felt as an expert group that all 4 were necessary in terms of interpreting how well a PRS was performing. All of them should be necessary steps in construction, but they should also be things that you comment on. So you can't really neglect commenting on any one of these. If you do it, you should report it for a lay audience to actually understand what's happening, because they all cover different distinct aspects in terms of the risk model evaluation. And the next slide. And then this is the last example that I have, just thinking about the reporting standard as a more holistic, I guess, resource for you all. This is not actually part of our reporting standard. It's part of a review that I was invited to publish after the reporting standard, and I'll put it in the chat. But it essentially creates a tie between the reporting standard and aspects for later stages of utility and translation, and how the definitions that we were very thoughtful about in the analytic and clinical validity stages actually are very important for informing utility. So I'll put that in the chat now. But just to know that the lens we had in mind in creating this was very much with clinical utility and translation in mind. The next slide. Okay, so I think with that, I'll probably hand it back to Jen, but both of us are available for thinking through next steps.
Sure. So, the next few slides are very short, but we're just thinking about next steps. So we published this reporting framework a few months ago. And so we're sort of regrouping and thinking of our next steps as we move into the next phase of ClinGen as well. And it's really important for us. Again, there are, at this point, I think a few years ago, there weren't as many efforts, but at this point in time, there are a lot of different efforts around polygenic risk scores. There's NHGRI efforts that I have on the slide here, the newly formed PRS Diversity Consortium, which starts up this summer. eMERGE, which is, I think, finishing up their first year about. And so we sit, trying to find a space where we can help both these groups, but not overlap too much in their efforts. There are also groups like the ICDA PRS Task Force, PGS Catalog, international groups outside of the NHGRI space, as well as professional organizations that I think Hannah already mentioned. And so it's really important for us as we move forward to really situate ourselves where we're uniquely suited, where ClinGen really has a lot of fortes, to make sure that we can help the efforts and in a non-redundant way, and really with an eye towards the ultimate goal, which is to improving clinical care of patients. So, I already we talked about this first goal of creating a standardized reporting guideline that was completed and finished a few months ago. And then, now that we've moved on from reporting, I think it's important to move to evaluation. So curation and evaluation. And so these efforts are ongoing and under development as we move forward. And then let me just check one thing. So when we think about next steps, this starts this summer. We are tasked with collaborating directly with the PRS Diversity Consortium and eMERGE, with the idea being that we can facilitate bridging the gap between them. So the PRS Diversity Consortium will be focusing on the methods and development of risk scores in diverse populations of non-European descent. And so they'll sort of develop the scores. And so we're going to be working with them to sort of bridge to say, okay, what does eMERGE need to evaluate the scores and go between those two worlds? And so that includes, what is the assessment of clinical utility? And especially, I think it's important to note that this is disease specific. So the third point on the slide here, the development of disease specific best practices. Part of when we were creating the reporting guidelines, we quickly realized that people's idea of what needs to be reported and maybe the standards within what needs to be reported do differ somewhat by the different outcomes because clinical care is at different stages, has different standards, different practices, depending on the outcome. So we saw a big difference between those working in cardiovascular disease versus breast cancer. And so the idea is that moving forward, when we think about the evaluation, this would be in disease-specific manner, so the best practices. And this is specifically with saying, you know, we're not talking about just the best practices statistically, you know, what is the best practice for data cleaning? More that what is the best practice to ensure that the PRS that you develop in your data set has the necessary components and the necessary information to move forward to being able to be assessed for clinical validity and clinical utility, essentially, and actionability for that specific outcome. Because the standards of actionability, and this is we're working with the actionability working group, are different. And so, you know, I think also something that's definitely changed in the last few years from when this group was started was that, you know, PRS are now actually available through industry, you know, venues. And so there needs to be a curation across both academic and industry spaces, and how we bring that together and how do we benchmark them against each other and think of how we can move together towards better clinical care. And I think it's also really important that we ground ourselves in LC considerations. And so we are collaborating with LC experts to look at the PRS specific ethical and legal implications. I think that it is sort of a different sort of lens to look at things through, especially when we think about clinical care, because PRS sort of, they stand on this line between, you can have these large effect sizes when they're combined together, but because they are genome wide and they sum small effects, they can often capture things that aren't directly related to the outcome of interest. So what is the, you know, societal ramifications? What are the ethical considerations for us moving forward to using these PRS in the clinic, you know, and making sure that it's both you know, valid and has utility, but also is equitable and also doesn't place any patients at risk. And so this is what we're doing moving forward, is finding this curation. And so, you know, I think this is, you know, we are regrouping now, so we are recruiting. If you're interested, please let us know. You can let either Hannah or I know, and we will include you in the listservs and the talks. So yeah, I mean, I'm happy to take questions with the few minutes we have remaining. And then I see on the bottom, there's already one question from Ryan. So I can sort of bring this first. Can ClinGen certify specific PRS models as clinically valid? So I don't think that, so the conversations right now are ongoing around this, but I don't think that we can work with, I think the goal would be to work with eMERGE. So the goal is, you know, ClinGen, as the first group pointed out, is around curation. And so the idea being that we take models that are developed, we work with eMERGE to assess the clinical validity of it because they have patient populations, the data, et cetera. And then we would have an expert panel that would be able to assess these metrics. And I don't know about certification, that seems very official of a word to me, but I think having some sort of evidence base and some text around, you know, what we believe it to be clinically valid or useful. Is that about it? Hannah, do you want to add on to that?
Yeah, no, I think that's the direction we're moving in. Honestly, the motivation behind creating a reporting standard is because it's so varied in terms of how people report in terms of like their clinical validity and utility. So I guess to an informatic extent, there is that that next step, particularly in collaboration with the PTS catalog, in terms of like, you know, quantifying that and having more like rigorous, I guess, evidence for assessing that. But definitely with ClinGen, so we're moving into our next phase of funding this August or September. And a huge area for growth in terms of non-Mendelian disease is interpreting the actionability of that information. So not just like whether or not it predicts disease, but what can you do with that information? So I mentioned during my talk, a lot of what we've tried to frame in terms of our standards so far had that clinical utility in mind. But I do still think there's going to be a need for coming up with, I guess, more theoretical ways for thinking about clinical utility, because that is largely, for the most part right now, what informs clinical practice. So we'll be working closely with that group and moving forward there. I think that's probably an area for Matt and Ryan in terms of how they think about these more like low penetrance risk alleles. Those of us that are in this, I think, clinically or research wise, it's not a new idea to think of this as a spectrum, but how we handle that in terms of actionability and how we implement this. It's a shifting practice, where are resources best put? All of those kinds of questions need figured out. And I think PRS are just kind of beholden to those same questions as everyone else in the long run. But I will mention for Jen and I, working with Emerge, who's already currently implementing, that's been a huge benefit because they already have the funding and the resources to do that. So we're definitely interested in figuring out those questions as we go. Jen, I don't know if you have anything else to add to that.
No, that's great. I mean, I will say that there is, I think that we might have skimmed over this, but there is the PGS catalog, which is an effort at EBI right now in the UK. And they already have really good job cataloging and everything, and they started moving into benchmarking as well. So we will be working both with the Emerge and the PGS catalog for clinical curation essentially of these scores beyond what the PGS catalog, which is more looking at clinical validity or analytic validity, and then moving into the clinical utility space.
But there's Ryan, I wanted to extend on what I had put on the chat. I know that sounds intimidating, certification, but I don't think it's too far-fetched. Like one of those important services that ClinGen delivers for individual variants, for example, is the expert panels, and then that ultimately goes into ClinVar, and it's been reviewed by an expert panel, and they assign a classification. So having that type of thing for the clinical validity of the PRS model would be extremely useful for labs and would help to operationalize more of these scores in more labs. Because if I'm the lab director, it needs to be clinically valid, but there's always that fear that I'm going to like slip on a banana because I pick some PRS that there's some technical flaw. So I think if there's a group of experts within your group that can kind of certify clinical validity at some level, I think that'd be helpful to the community.
Yeah, so I mean that's definitely something I think we can put together, and with the ultimate goal. I think it's somewhat dependent on the timelines of Emerge, which are working through the data and the scores. But I do agree that that's sort of the ultimate goal, and hopefully we can get there. I can see how that'd be useful. One thing also to note about that is that there is, one point of contention for the risk scores is that, which I think might be a little different than other parts of ClinGen, is that there is, because a lot of the risk scores that might be available to patients come from an industry space and not an academic, there is issues with sharing of that information. And so one of the things we think about moving forward is sort of how do we provide this clinical, certification or any kind of assessment of these risk scores when they can't, how do we share that data across industry when there are commercial concerns versus academic spaces. So that's definitely something we are trying to navigate as we move forward and sort of build those partnerships. And I also think maybe ClinGen is uniquely suited to do that, given both the membership within our working group for ClinGen, which does span both industry and academic spaces, as well as the people sort of that we're communicating with.
Yeah, I'd agree with that. I think in general, like with that process map I kind of showed in terms of our like stakeholder assessment, I think that's really changed. When we started, I think this group was started in 2018. So PRS were starting to be kind of exponentially reported on, right? But they weren't as prolific to the extent that we had like commentary or users of it. But I think in the last few years, it's really been available commercially and in other venues. So I think that's something that Jen and I are having to adjust to, like how do we have like non-published voices, right? Like who are the users of this? Who are the clinicians that have had to act on this information? Who are the commercial bodies that have actually tried to implement this? So I think that is something we're definitely considering in collaboration with eMERGE and the PRS consortium, in terms of like what are other data sources that aren't the literature, because a lot of what we published is on the literature. But yeah, ourselves, the PRS or PGS catalog, we're all just trying to figure out, how do we involve the other stakeholders in genomic medicine? Because I'm sure all of you on the call have had some, sampling of what genomic medicine looks like, and it's often not always controlled in terms of academia and kind of these literature sources here. A lot of it is pushed through by industry.
For the sake of time, I just wanted to note that the next session up is at 11:45, and there's the posters. The link is there if you want to do it. But I also wanted to note that there is a question for the low penetrance group in the chat from Dimitri about if there's time for folks to answer. Are there any efforts exist on creating registries for individuals with low penetrance and or risk alleles?
This is Ryan. I'm still here. I can't think of any specific registry other than ClinVar, but there's also these variants being considered within the individual subject specific working groups in ClinGen.
Also, we are working with the CDC on creating reference panels of variants that may be tricky to detect or be missed by filters for exactly the kinds of reasons that we're talking about here, because they're low penetrance, they may be higher allele frequency, and a filtration system that cuts, sets it at 1% may miss a hypermorphic allele or something. So we actually just posted a paper on bioRxiv for the first version of the GetRM reference materials with the variants nominated by our variant curation expert panels. So that resource might be one. It covers a variety of different types of variants, both analytical issues as well as interpretive issues. And we also have a high allele frequency list on the ClinGen website. Those were meant to be over 5% allele frequency that's there, and you can nominate alleles. But I think this group should think about what resource, and what exact formulation, and we could support posting one on the ClinGen website based on what you all come up with.
Yeah, I was gonna say, I think we had hoped to eventually have anything that we classified ourselves or classified in combination with like a disease group to have hosted on the ClinGen website. So there's a clear reference point for people to tackle or to go to.
Yep.
I
I'm
guess,
going to post, go ahead. I'm just going to post that medRxiv paper in the chat right now if anybody wants to look at that.
yeah, I was gonna say on behalf of like the complex disease PRS group. So I currently work with like a lot of primary care providers. A lot of what we're predicting with PRS is common complex disease. It's not solely dependent on the genomics. It's complex disease. It's a combination of the environment, lifestyle, and the genetics, which is part of why we called it complex disease, not polygenic risk work group. So I think it's also really important to like be aware of what the training is there. Certainly at Stanford, that's a lot of what has consumed my last few months. Just working with the primary care departments here and how they learn about multifactorial disease and preventive screening in general. So I would say like the idea behind a lot of these concepts, at least at PRS, I won't speak on behalf of the low penetrance group, but a lot of what we're doing, the idea is not novel, right? Like we've known a lot of common disease is multifactorial. We just now have a mechanism for quantifying that. So I think as much as we need to also build new practice in genomics for, labeling these things and dealing with them, it's not new. Like we also need to be aware of other stakeholders in this process, other people involved, other ways that they've explained it, and integrate with those. And I know for a lot of genetic counselors like myself, multifactorial counseling, it's not a novel thing. You've done it before. So as long as you can rely on like the body of literature and evidence and training that's been done before this, just think of that as something to add to, rather than this being a novel thing. And I think that helps a lot in terms of how to think about this.
Okay, I mean, I think we're over time now, so I'm gonna let people go and have their break before 11:45. But I think from Hannah and me, if anybody has any questions or like to join, please reach out to us. And I'm sure for the same thing for the previous group as well.
Yeah, definitely. Thank you everyone for the awesome questions too.
Yes, very good questions. I think we were told to advertise there's a poster session.
Yes.
Jen has the
Yeah, it's
link
up there.
here. We'll also put it in chat, I guess. Maybe that's more accessible. Yeah, I hope everyone has a good rest of conference.
Thank you.
Okay.